So someone of you has already has experience with Python. So I would like to ask you some patience for today. So I would like to start from scratch for those of you who has not experienced before. So I would like to have an introduction to Python, but starting from the next week, I will go a little bit quickly because I would like to show you from the next week directly to work how to work with signals and how to deal with algorithms. So for today we will have a very general introduction to Python. Of course, we will focus on all the things that we can, all the things that are related to this course. So we don't have explanation of general concepts that can be outside of this course. So we try to learn step by step, and we try to uh, to learn something that of Python that can be useful in order to implement machine learning algorithms and apply these algorithms to signal processing. So for today we have this kind of general introduction. I would like to show you first these few slides just to have a quick presentation, a quick introduction, and then we move to some practice in order to take confidence with coding in Python. So as I said, we will introduce with Python and Python coding, and we will understand its potential in machine learning for signal processing, and we will just learn how to set up our environment in order to get ready to get in practice the theory that we will see. So for many of you, this can be just like a boring presentation. So I'm going to give you some useful, basic but useful information about Python for machine learning. So as I said, I would like to remember that the scope of this course is not to prepare you to solve programming problems, but we want to solve signal processing problem using machine learning algorithms. So the focus is not to learn Python as a universal programming language, but I would like that you learn Python as a fundamental tool to implement your algorithms and to solve your problems. So we need to understand theory, but we need to be able to use all the possible tools that can be that can allow us to implement machine learning algorithm and take take it take it soon as a possible application. So take your hand in any application. So I would like to give you some the fundamental theory of machine learning, but I would like to also for you to implement this kind of theory. So put in practice the theory that we will study. But to do that, we need to take confidence with some tool, and Python is one of these tools. But we will use it just to as a tool to get in practice, to write your algorithms and solve your problems. So for today, I will give you an introduction, but we will approach to Python step by step. So we will we will have lectures and lab sessions. So I would like to give you the right theory, the right amount of theory, and in parallel I'm going to show you how to implement the most useful algorithms, some of the most useful knowledge that can be that can allow us to implement anything that we will study. So we start just by asking what is Python. So Python, as many of you know, is one of the most popular programming language for machine learning. Is very easy to learn, and at the same time it is very powerful for machine learning applications, for machine learning algorithms. It has a high-level data structure, elegant syntax, and dynamic typing. It is an ideal language for some kind of rapid application development, and it has an interpreter that is freely available. It is an open source language, so you can access to anything related to Python very easily. And this fact, also being an open source software, it has a very rich development community. So if you don't have used Python before, you may find a lot of Python tutorial in this slide presentation. You can find a lot of useful link in order to find tutorials and other things related to Python. Just some basic glossary, so I don't want to boring a lot, but I just want to give you some basic knowledge, some basic glossary in order to be understood when I speak to you during lab sessions. So one of the basic object in Python is a module, which is an organizational unit of the Python code. Is nothing but a file.py, which contain some executable code of Python. And so it is the basic object of Python, of executable code of Python. And it is basically a file which is denoted by .py. So a package module, a package is nothing but a collection of modules, but it is basically a directory with files. So each module, technically a package is a Python module with some attribute that denotes the path, so the directory with files. It must contain an initialization file so that Python can interpret that file as that collection of file as a collection of modules or also a collection of packages. So a library is very there is no some real difference between library and packages, but you can see a library is a collection of various packages, and we will see that we will use a lot of libraries of Python. And a framework is a collection of various libraries that architects the code flow. So the difference is that the library, in the library you can use your library, you can use your modules within your library to write your algorithms, and you can use the framework in order to build a code flow. So you can use predetermined precoded files, precoded library in order to build your code flow. So we can say in a funny fashion that a module can be your fingers, one of your finger, a package can be your hands, or a collection of fingers, a library both your hands, so it can include also packages, and a framework is the whole body. So I would like to introduce you this basic glossary, but you can find an extensive glossary on the Python website. So you can find a lot of resources on this website, and so I think that you can learn step by step. But if you have some curiosity, you can find a lot of material online. So uh, you can try to start and then take confidence with this programming language. So I would like to talk about libraries. So due to the fact that it is an open source software, we have a large communities. So we have also a large number of packages and libraries. So um, a library so can, as I said, describes a collection of core modules, and the Python standard library is a collection of syntax and other things of all related to Python, and it is also included in the Python distribution. This library is written in C, but so all the functionality, it includes all the functionality that make Python a language as it is. So you can find all the packages in the some useful packages in the Python standard library, but you can also install additional packages that can be installed by use the pip command, but you can also update the packages just by writing this command, this line inside your terminal. And I would like to also say something related to the most useful Python library for machine learning for signal processing. So we mainly use the NumPy the NumPy library to manage data, to manage multidimensional arrays, to store data and manipulate data. We will use matplotlib library to visualize some data, so take some plots and I don't know, some graphs that can be describe your results and so on. The SciPy library that provides a lot of user-friendly and numerical routine, so like numerical integration, we will use a lot in order to manage signals. It contains a lot of operation that can be done on signals. So we use a lot also SciPy, and we have other. Some of these libraries have been developed to upon some lower layer of Fortran and C in order to be very fast when they are used. We will use also another library which is called Pandas, and which provides some additional high-level data manipulation. It is very useful when we need some when we work with some data that can be presented as a tabular data, and we will see a lot of application that can be in which it will be very useful. Another application, another library is scikit-learn that we will definitely use, which contains a lot of machine learning algorithms, especially for classification tasks that we saw yesterday. So, and in the last part of this course, we will use something related to the TensorFlow library, especially to deal with deep learning model very efficiently. So these are some of the main standard library for machine learning for signal processing, but we will use other kind of libraries, but step by step we will introduce them. So we need to download, of course, the Python distribution. What is a Python distribution? It's just the whole environment that we need to run our software. So we start just by describing Conda, which is a Python open source package management system, and ensure that we have all the dependencies of the software that are connected. So Conda can create your environment and can manage the environment on your local computer, and it is also called an environment manager. So it just manages the environment and all the packages that are related to the environment of your package. We use as a Python distribution the Anaconda enterprise software. So it is a Python distribution. What does it mean, a Python distribution? That it contains all the essential packages that we are going to use, especially for machine learning. So I guess that all of you, I hope that all of you followed my instruction that I sent you by email and installed the Anaconda distribution. But if you didn't download it and install it already, you can find it now. You can try it now to install. It is very simple. You can go to the Anaconda page and install the distribution. So I'd like to tell you something related to this the installation, because I have now a laptop, a Mac laptop, and I managed some difficulties in installing the last version of the Anaconda. So if you have a Mac, I suggest you to install the version 2.7. While if you have Windows, you can install the 3.7 version. If you didn't do already. So Anaconda includes the Conda package and environment manager, and you can after installing Anaconda, you can install additional packages in an alternative way. So instead of writing some instruction like this one, you can just use this command, which is more easy and more stable. So I suggest to always use these commands for install new packages and to update some already existent packages. Once you install the Anaconda environment, you need to choose your Python development environment. What is an integrated development environment is nothing but the interface that can manage all your code and can manage the environment in which that you are using. So a simple choice is to adopt Spider, that is already included in the Anaconda distribution. So when you install the Anaconda distribution, you can find also this ID installed, so the Spider software, and you can launch it and use it as your software, as your development environment. So Spider offers a combination of advanced analytics and editing and so on, debugging, profiling functionality, and so on. And you can also use alternatives to Spider like Visual Studio Code. But I would like to just show you, so I have installed my Anaconda distribution, which is here. Okay, so this is the Anaconda Navigator on my Mac laptop, but you can find some similar on Windows or on Linux. But you can, after the installation, you can find some useful tools here. So here is Spider. So I have installed the version 2.7, but if you install the version 3.7, you can find version 4.0.1, I think, of Spider. So you can launch Spider, and you can see the environment of Spider. You can also find the Visual Studio Code here if you want to use Visual Studio. I don't know if you have experience, for example, with other programming language, and you have experience with Visual Studio, you can use Visual Studio as your development environment. So this is the environment. So here is the editor in which you can write your code. You have the console and so on, other kind of things that you can discover by yourself. But it is a very friendly as an interface. It is very similar to MATLAB if you have experience with MATLAB. So I think you will use it very easily. And you can also try Visual Studio Code as an alternative if you prefer. In this course, we probably use this. We use Spider or any kind of other development environment when we need to check some advanced project, when we need to use some libraries and we need to build some collection of modules. So we need different files, different modules that can be created. But during our lab session, we mostly use the Jupyter Notebook. So it is another application that allows you to create and share documents containing live code, equation, and so on. And they have the suffix. Their files have the suffix, which is different. So it stands for Python Notebook. And you can find all the documentation again. You can find on the website, on the internet, a lot of documentation of every of these these things. So you can, if you go to the Anaconda Navigator, you can launch Jupyter Notebook, and you will see a page on my browser is opening with Jupyter. So Jupyter is a local software that can be run on your browser. So this is the home page of the Jupyter Notebook, and here you can find some folders, and inside the folders you have your files. So then we will use Jupyter Notebooks, and in the rest of the lab session we mostly use Jupyter Notebooks to have live coding sessions. An alternative to Jupyter Notebook is the Google Collaboratory, or just called, so I need to modify this one, yeah, or just called Colab. It is very useful because you don't have any need of prior configuration. You can. It is the same of Jupyter Notebook, but it is hosted by Google. So you can create your notebook and they are directly stored in your Google Drive. So it is very easy to share your files and to store your files on Google Drive. And you can also use a lot of Google services. You can you can leverage the power of Google hardware. So okay, you can use the GPUs and TPUs of Google that Google uh, makes for you. And you can find a lot of other resources related to Google Colab online. So if you want to take a lot of material. So during lab session, you can use, as you prefer, Jupyter or Google Colab. There is no difference for me, as you prefer. So if you use Google Colab, you can store your lab sessions in your lab coding in on your Google Drive. Otherwise, you can store your files in your local computer. So we can have other Python resources. So you can use, for example, I don't know if we use all these additional resources, but probably you can see something related to Apache MXNet, which is a library for coding develop deep learning models using parallel GPU cores. There are a lot of other devices, other libraries related to this thing. And if you want to use your code on GPUs, you need to install the necessary drivers for the GPUs. You can find a lot of additional resources and a lot of documentation about NumPy, SciPy, Matplotlib, Pandas, and all the other libraries that we will find. So there is a very large community, and you can find a lot of well-done material online. So you can just learn the basic things following the following this following our lab sessions. But if you want to go a little bit into detail, you can find a lot of material online. So I think it is a good thing. So for today we stop here with the slides, and we move to have some practice with Jupyter, with Python. So this is something related to the next week. So the next week we will go a little bit into detail of some linear algebra refresh, but please don't think to linear algebra as something that you study in your first level degree. So I know that there is something boring, but we will use just the most relevant notions that can be used for this course. It is very important because we will introduce a lot of structures to store and manage data. So I will introduce a lot of signals and how to manage signals. So linear algebra is an important tool, is a fundamental tool for machine learning, for signal processing, and you can think to it as a Python tool. So you can use linear algebra in order to write your algorithms, and it is fundamental because when you have some kind of signals or some kind of data, you may quickly think to the most useful structure to be used and to manipulate and process data. But we will talk about linear algebra and signals in the next week. So for today, I would like to start with some basic syntax, basic introduction to Python in Jupyter. So I would like to have some a first lab session. Before starting, I would like to know if you have some question. I would like to know if there is something that you didn't catch or anything else. So please don't be shy if you have some doubts, if you have some question to ask. I hope that all of you has the Anaconda distribution installed. Uh, if you have anything that is not clear on, if you have some also general question, don't hesitate to ask me. Otherwise, I go ahead and we move to Python. So, okay, I don't see any feedback, so I go on. And I can open, so I've opened the Jupyter Notebook software. So we can move to Jupyter and we can, I don't know, you can create a folder. So you can go here, you can create a folder in which you can store all the files that you want. You can also go, I don't know, in documents and so on. You can go, I don't know, whenever you want to store your files. I have this, these are the lab session of the previous year, but you can create another folder and store your files. Okay, once you created your folder, so here is my folder. So once you go to your folder, create your folder, you can start a new Python notebook. So yeah, I think a slow connection. So if you manage something that is not very, it is not working, if your connection is not working so good, just let me know if I need to repeat anything. So it is very slow, but we just need to be satisfied with this means. So here is a Python notebook. You can start, so it is a very simple interface. You have just one block here. You have some very few things here, some very few commands here, and you can use any blocks to write code or just writing text. For instance, the first thing I want to do is writing text and giving some heading to our notebook. So I can write, okay, this is the course of machine learning for signal processing. So my suggestion is to split your window. So you split your window and create two windows. So in one window you can see all the things I'm writing to you, and in another window you can so you can put your two windows in parallel, so you can watching what I'm going to write in my notebook, and in parallel you can use your notebook to write the same instruction that I'm that I'm writing. So in order to take very soon confidence with your notebook and with the Python coding, so it is a lab session 1, and I don't know, you can write your name and so on. So you can write some basic information here. You can put here as a heading, but it is useful because you can also write here some HTML code, and so you can also use some instruction. So here is some heading instruction. And I can put, for instance, my name, and date. Okay, once you wrote your text, you can run and see the results. If you want to edit again, just clicking 2 times on the cell and go ahead. So when you run your code, you can see the format of your code. And in this time is a markdown type, the cell is a markdown type because you can write your code, your text. If you want to code, you can directly take a cell like a code cell, which is the default choice for any new cell. If you want to add by yourself a cell, just click on the plus symbol. So I would like to show you some basic and starting from the syntax. So Python is a very simple language. It has a very straightforward syntax, and I think the simplest directive in Python is the print directive. So you can just simply print out the line. So you can simply print welcome to the first you can run this code and you can see the result. So you have printed your instruction, and this is a very simple instruction that you can find. So one of the useful thing in coding, but in every language, are comments. So comments are fundamental when you are coding, because you can write anything that can help to understand your code and to understand what you are writing, especially when you write some very complex algorithms, and you need to write a lot of lines of code. It is very useful to write some comments in order to understand what is written, and in order to have a clear view of what you are doing in any moment. So in Python, comments can be written by using the hash character. So you can write here, this is the hash character, and you can write your comment. So this is a comment. So you can write the comment at the beginning of the line, but you can also write some code like this one, or I don't know, any kind of text, any kind of extraction, and this is another comment. So you can write it also after the instruction. And you can see another important thing of Python is the indentation. So it is very fundamental to indent the code when you write, because Python uses indentation for blocks. So blocks are, for instance, loops like for loop and if loop and so on, instead of using braces, curly braces, or other kind of parentheses. So you can write, for instance, some code. I don't know, any kind of code. For instance, x equal to 1, and you can write if x equal to 1. So this is the start of a block. So I'm starting a loop, so an if block. And if you want to continue with the instruction, you need to indent your your code. So this is, so at this point you don't need to write any and or close any parentheses, just writing code in this time, in this way. Okay, so I just we can go back to have some instruction. So this is a very basic C syntax. So you write some block here. So this is a block of code which is related to a loop, and inside the block you need to indent your code. So once the code is finished, you just need to remove your indentation once the block is finished. And then you can have a lot of other things. For instance, you can have some variables and types. So Python is completely object-oriented. So you don't have to declare variables as similar languages and declare type variables. But every variable in Python is an object. So we can try to have some few examples. And Python, starting from numbers, we can manage numbers in some way. In this way, so Python supports integer and floating point numbers. We can start by defining an integer number. So here is an integer number, and you can print okay, you have this integer number, but you can also have a floating number, just writing dot after the number. And you can see this way, but you can also write it alternatively as in this way. And you have the same result. So, or you write the float directly, or you can write the integer number and then force the type of your number to be a floating point. So you can have expression syntax with numbers, which is very straightforward. So you can use the operator plus, minus, the times, and the multiplication and division, which work like any other languages that you know, for instance, C or MATLAB. And you can use parentheses in order to group numbers as usual. So you can just write two numbers and have and write numbers and have very simple operation. So I don't know, you can have some kind of code like this one. So you can use parentheses to manage to group operations. Can also write this operator that returns the remainder of a division. And another thing that is different from other programming languages, the power, so the elevation to a power. So if you want to write 2 to the power of 8, you can write in this way. So the double asterisk, you can write in this way to have 2 to the 8 in this case. You can use the equal sign to assign a value to assign a value to a variable. So we just introduce numbers, but if you want to store our number in a variable, we just use the equal sign. So for instance, my number is 19, so this is the variable my num, and the result is 19. So you can use your variable as a number, so you can just write something like this one and having results, so you can then use your variable as you prefer. You can also use strings, so instead of numbers you can also use strings. So I don't know, you can write your name. So in order to write string, you can use single quote or double quotes. So you can use single quotes like this thing and print my name. But you can also use double quote and having the results the same. What is the difference? The difference is that if you use double quotes, it is more easy to manage apostrophes. So in this way you can, if you write an apostrophe here, you have that you are closing the string. So if you go to print, you have an error. While in this case, if you use some apostrophes here, you don't have any error. So it is the double quotes may be useful in this way, but for any other thing is the same. So string can be concatenated and also can concatenated with the operator plus, and can be also repeated with the operator of the multiplication. So for instance, we can write, I don't know, something, you can write anything you want, so machine learning, and you can also write, I don't know, signal processing and MLSP is the result of ML. I don't know, you can write some blank space and you can write some other string and you have the result. Which is machine learning for signal processing. So you can use the concatenation as you want. I don't know if you want to write some repetition. So you can write, I don't know, some kind of I don't know if you are very enthusiastic of the of your machine. And so there are other things that you can do also with strings, but we can go ahead. So you can check also the type of a variable, for example, just by writing, I don't know, the type of, so my num. So it returns the type, which is an integer number, or I don't know if you write type of my name is a string, and so on. So you can also check if your, for instance, my name is an integer, and you can see that it is false because it is a string. So we can move to some data collection types. So in Python we can have 4 data collection types, which are list, tuple, set, and dictionary. We will work with lists and sometimes in some cases with dictionaries. So list is the most important data collection type for what is related to our course. So a list is nothing but is characterized by an ordered and changeable sequence of entries of elements, and it can be used as an array for storing multiple entries in one single variable. For instance, you can write my list and I don't know, you can write your list. You can write numbers, but you can also write different type of elements. So you can write, for instance, integer numbers, but also a string here. So here is my list, and you can, I don't know, measure the length of your list just by using this command len, and the output is 4, the result is 4 because you have 4 elements. So it is very important, the positional indexing of an array. So my list. So in Python, like C, the first element of our list is denoted with index 0, while in MATLAB the first element is indexed by 1. So this is a very basic difference between other kind of languages. So you can write my list 0, so you are accessing to the first element of my list, and the result is 1 because it's this element. So if you want to access to the last element of your list, you can write -1, my list, not my last, and you have the last number. You can also try to return an interval, a range within your list. So you can slice your list. For instance, if you want to return the last 3 elements of your list, you can write in this way. So -1 returns the last one. If you go to the -3, in this operation I'm going to say, okay, go from the -3 element to the end, and here is the result. So it is another string, another list which contains a subset of my list. So you can also try to use some methods, for instance, to append an element to the end of the list. So we can put the element 6 at the end of the list, and you can also print my list now, So we have another element here. You can also add, you can also insert an element inside the inside your list. For instance, if you want to add number 4 here between 3 and 5, we can just insert the number okay, so I need to okay, this is the correct. So I'm going, so I am inserting in the third position, so in the third position, which is in the index 3, so which corresponds to the fourth position, the element 4, and it is the results of our operation. So we can also try to replace some values. For instance, we can replace the element from 1 to 4 with this other. So from 1 to 4, I'm going to say that I'm considering the 3 elements, because we are considering the number 2, so the index 1, which corresponds to the 2, the index 2 and the index 3. The last one, which is the index 4, is not included. So when you write an interval, you need to consider that the last element, the last index that you write, is not included in your range. So in this way, you are considering 3 elements from index 1 to index 3. So we can replace some elements. I don't know, we can write something like this. We can also replace in this way and print my list. Okay, so I changed these elements from 2 to from the second to the fourth element. And we can also concatenating some list. So we can add another list to my list. I don't know, we can add 7, 8, and 9. So I generate, so in this case I just print my list, so I didn't store this new list in another variable, but I have just printed my result. So you can also create a sequence of values. For instance, you can write in this way. Using a range, you are going to create a sequence of elements that goes from 1 to 16. Also in this case, the last number is not included. So you are going to create a number of 15 elements that starts from 1. And we can also create, you can also take a step here. So you can also can create your sequence with a step of 3, and the result is this one. So you can create whenever as you want your sequence. You can also try to loop within your list. For instance, you can use the for loop. When you write some loop like this one, please don't forget to put the double dots here. So for X in my list means that you are considering X that goes from 1 to the end of your list. Here you need to have indentation, so if you press enter, automatically you have indentation because you are starting a block, a coding block, and print X. So here is the results of your coding, the looping over a list. You can also loop over two lists concurrently. For instance, you can define two index I and X in enumerate my list, and you can print, for instance, element. So you can write print a string. You can write the first index, another string, and the second index. So the first number is just the index, and the other one just take the element from your list, and the result is this one. You can, the last thing on the list, you can also have the list comprehension, so you have your filtering inside your sequence, so you can write your variable and you can put that you are multiplying two times, you are multiplying each element of your list for X in my sequence if the rest of the division by 2 is equal to 0. So I hope I have written correctly. Okay, so this is the result. So I'm multiplying the elements of my sequence for 2 if the division, the rest of the division by 2 of the number is equal to 0. And I can just introduce the dictionary very quickly. So if you want to make a different data collection that is not a list, but so the list is a data collection that is characterized by an ordered and changeable data, an ordered sequence of entries of elements. But if you want a different data collection, a dictionary allows us to write elements in an unordered way. And for instance, we can write our dictionary in this way. You use curly brackets and you can write some key. I don't know, you can write your first name and the result of your first name, the attribute of your first name, and you can write other keys, last name, you can write, I don't know, gender, name, age. So for instance, my age is 19, so you can trust me. And here is my dictionary. You can access to the to this dictionary by just calling the key. So for instance, if you want to know what is my first name, I can write in this way, and the result is the attribute that I wrote. So you can also loop within loop over a dictionary in the same way of the loop over a list. So I can write in this way d dot keys, because I'm looping over the keys, and I can print the attribute of the key. And if you see, you have a different order of your attributes, because it is the dictionary is not ordered, so you can take the results in different way. So I can move to define functions, but before moving ahead, I would like to ask you if you have some question, if you have if you can catch anything, if you are boring or other thing. Okay, so you are writing. Okay, you have a Mac and you have Python without problems. I don't know. I don't know. Probably depends on the kind of operational system. I don't know. I manage some difficulties in updating my Python. You always use Colab, so it is a good choice because it is the same. So when you use Colab, you have all the files in your Google Drive. When you are using Jupyter, you have your files in your local laptop. So okay, it's Python 2 that defines it. Yeah. Okay, good. So it is very useful to have a chat with you, so each one of you can also write your experience. So I move ahead and try to briefly introduce what is a function, because it is very useful when you are coding, when you are writing algorithms, that you define some function that can be an algorithm, and so you can reuse some code. So functions are convenient in order to divide your code into useful blocks. So when you need to reuse code, when you want to save some time, and also have some more elegant code, and some code that is very useful very easy to use. So functions in Python are defined by using the block keyword def, so followed by the function name. So for instance, def is a key keyword of the block, and if you note, when you write def is colored in green. Here you can write my function. You can write a function without any arguments, and you can just write an instruction. So look here, you have an indentation because you are starting a block, so you need to indent your code after the block. So the definition of a function is like a loop, so it requires indentation. So please remember to always to indent your code. So you can write just a simple sentence. I don't know. You can write anything you want. So you can write all the things that you want. So here we have defined this function. So how you call a function? So a function can be simply called by writing the name followed by the parentheses in this case. So I just called my function, and we have the result. So the result is the statement that we included in our function. We can also try to set some arguments in our function. So we can define a new function. I don't know, my function with arguments. For instance, you can use your name and some you can insert two arguments here, so you can write an instruction that uses these arguments. So for instance, you can write in this way, so you can write, I don't know, yes, you can write hello, I don't know, you can insert the username here. Since the username is a string, you can define the username in this way with the percentage symbol and the S letter. And you can insert the greetings here. So you close the string and you put here and you can call it just writing my so here you put your arguments, so you can write the string, so your name, you can write your name and a greeting, so for instance, and okay, you have the results, so which is the string that you put here. So you can also try to have a function with using or you can also use the return statement. So for instance, we can define the sum of two numbers. For instance, two numbers A and B, so they are generic values for our input variables, input arguments, and you want that this function returns a result. So in order to do that, we can return A plus B. So this is our function that take two input numbers and return the results. So in order to do the results, we can write, for instance, x equal to some number, and I don't know, you can write two numbers as you prefer. And you can see the result, which is x. So there are some other things that I can put in your additional material. Since we can move a little bit ahead and try to introduce, you can find a lot of other materials that you can find on the tutorials that I'm going to I will give you some additional, some useful links in order to find lots of material, lots of, I don't know, tutorials and exercitations and so on. But I think that we can move on and try to introduce some basic libraries that we are going to use. So I think that most of you will that have practiced with Python is very comfortable with using this kind of concept that we introduced. So we are going to introduce very briefly some kind of libraries that we are going to use often in this course. The first one is the NumPy library. So for instance, here in our lab, so I never wrote any other text here, but of course you can put your any text here in order to take some notes. So for instance, I don't know, you can write some notes about the, I don't know, here you can write some notes. If you want to have some comments and so on. I never wrote any comments here, but I will give you a comprehensive notebook, included some comments or at the end of the lesson. So you can also write here some text, and you can change the arguments. I don't know, we can write NumPy library. So we can start a new argument here, and we can start this talking about NumPy. What is NumPy? NumPy stands for, it is the short for numerical Python. So it was born as an open source library, as most of the libraries of Python, and it has evolved into an essential library for scientific computing in Python, and we use NumPy a lot because it is a very convenient interface to work with multidimensional array data. So we can use basically with vectors and with our matrices and so on. So we can organize our data, arrange our data in some multidimensional data structures. The first thing is to import the NumPy library. So in order to import any library, we need to use the command import. So the keyword import. So you can see that it is colored in green. We can import NumPy, and we can use any command of NumPy as the prefix np. So I'm going to import NumPy. So here is, so now NumPy is imported. So NumPy the main data structure is the multidimensional array, which is denoted by ND array, so an n-dimensional array. And we can think of a one-dimensional array as a data structure to represent a vector of elements. So in the same way, we can think to a two-dimensional array to represent a matrix, and so on. So a tensor is a three-dimensional array, and so on. So instead of thinking to a vector rather than a matrix, rather than a tensor, we can think to a multidimensional array with a certain dimensionality. So we have several ways to create arrays. One of the most common is to using this kind of commands. So we want to create a one-dimensional array. So we use this command array with the prefix np. So np array, and we try to write our list that is interpreted as a vector in this way. So we can also print x, and we have our array. So this is our vector. So more than you can refer to as a vector, but in a more correct way it is a one-dimensional array. But you can also create a two-dimensional array in order to have a matrix, to represent a matrix. So for instance, you want to have a matrix of 2 rows and 3 columns. So 2 rows and 3 columns, you have the 3 columns and the 2 rows. So you write the first row and then the second row. So here is my, so we can write np.array of a. Okay, so here is our matrix of two rows and 3 columns. So I can write I matrix in this way, so writing rows by rows, row by row. And you can also you can also ask the kind of type of your dimensional array, multidimensional array, just asking what is the type. So the type here is int74 because by default is that the ND-array object should be of the type of your machine. So if your machine is a 74-bit machine, the type is int64, 64, sorry. So if you have a machine that works on 32-bit, you have int32. So you can also try to ask what is the dimension of your matrix. So you have the shape, the size of your array. So the size of your array is 2, 3. So 2 rows and 3 columns. So the shape just returns the size of your array. And another important thing is to access to the element of your array. So one-dimensional array can be, and also every dimensional, multi-dimensional array can be indexed, sliced, and also iterated like we saw for lists. And you can have one index per axis, and any indices are given in a tuple separated by commas. For instance, we can make an example of a random matrix with elements drawn from a uniform distribution. So in this way we take some confidence also with this kind of notation. So we want to have a uniform distribution which is done by the command random.rand. So rand stands for random following a uniform distribution, and but you can also have a normal distribution like MATLAB and so on. We will come back later on this kind of functions. So here we have a matrix of 3 rows and 2 columns, whose elements are are drawn from a uniform distribution. So you can return the first row of the first entire row of the matrix just uh, by using this notation. And you can see you have the first row, or you can access the element on the first row and the second column, or you can access, for instance, to the, I don't know, you can write something like this way. So you are asking to return the first two elements of the first column. So we have the first two elements of the first column. So you can also ask to return all the rows from the third on. For instance, you can write in this way. So you are asking from the index 2 of the rows on. So index 2 is the third column. If we have a matrix, a larger matrix, we have other two columns. For instance, we can write here this way. We can have 4 columns. And here you can see that you have the last two columns, the last two rows of our matrix. But you can also write the same by writing in this way. So you are saying, okay, not from the 2 on, the second, the third rows on, but we just forcing to have the last 2 rows. And we can create also we can have a lot of some useful function, like in MATLAB, for instance. You can have that you can create a matrix of ones. So it is very similar to MATLAB in that sense. You can have a matrix of ones. You can also copy. So the copy is a fundamental instruction in Python. If you want to copy an array, a multidimensional array in MATLAB, it is very easy and simple, because you can do something like this one. So you are taking a new variable b that is copying a, and you can print b. So you have the same results of a. But if you are going to modify one element of b, for instance, I put a 0 in the first element of the in the second element of the array, so in the first row and the second column. If you print b, you can see that I have modified the element on the first row and second column of b. But what is happened that I have also modified the matrix A. So B is not a copy of A, but it is an alias of A. So if I print A, I can see that I have modified also A. So how to copy? So the correct version of the copy is to have I don't know, if I want to copy this matrix, the right command is this one. So here is B, and so in this way I have copied in the correct way a matrix and a multidimensional array. So NumPy also has lots of statistical functions to find the minimum, maximum, standard deviation, and so on, the variance. It is very similar to MATLAB. So also in the notation and in the name of the function, we can find lots of similarities with MATLAB. So for instance, I can create a matrix which is, I don't know, NP array and we want to know the sum of all the elements of the array. So I use the method sum, and I have the results of the sum of all the elements of the array. But you can also have the sum, for instance, of the sum per column. I just write axis 0 in order to have the sum per column. So it is more clear. So you have the sum per column here, or otherwise you can have the sum per rows. You can also have some other things like variance or I don't know, standard deviation, and also in this way you can consider one of the column, one of the dimensionality. For instance, in this case I want to know the standard deviation for each rows. And the last thing I want to tell you that is fundamental for NumPy is the which is very different from other languages, is the broadcast. So the term broadcast describes how NumPy treats arrays with different shapes when we take some kind of arithmetic operations. So if for example, if we use a smaller the smaller array subject to some constraints, for instance on multiplication, the smaller array is broadcast across the larger one. So in order to have some compatibility of the shape. And here is an example. So imagine that we have our multidimensional array, so we can have the uniform distribution. We can print A. So we have a one-dimensional array, and we create another multidimensional array which has different shapes, different sides. So we have a row vector and a column vector. So we have a row vector of 2 elements and a column vector of 3 elements. If I take this operation in MATLAB, for instance, I have an error because the dimensionality is not correct, because I'm going to multiply a vector 1 times 2 for 3 times 1. Of course, we don't have the same dimensionality here of the columns of the first structure with the rows of the second structure. So we have an incorrect operation. While in Python, this operation returns a result. So what is happened? It's happened that Python has broadcast the element with the smaller size across the side the dimensionality um, of the larger array. So the result is similar to having something like this one. So the first this matrix, this vector is considered in this way. So I can also write only A because we have just one row. So I'm considering the replace of the first row in 3 times. So I have repeated the first row 3 times, and in this case we have the same dimensionality of B, so I can take this multiplication correctly. So I had the same results of having a matrix like this one. So instead of having a matrix like this one, I only add this vector, and it is broadcast in this way. So it is broadcast, so it is repeated in order to match the right dimensionality to have this multiplication. And it is a very fundamental operation in Python, but it is also dangerous because when you are not put into attention, into consideration that the right dimensionality, so you always need to consider the dimensionality of the structures that you use, because in this case you didn't have an error, so you have a result. And if you don't understand that the dimensionality is correct, you have the result, but this result can maybe not correct. So in several ways it is better to have an error that have a wrong result. So you need to always pay attention to the results and to the dimensionality of the structures that you use. So I think that we can come back to NumPy in the next week when we introduce some linear algebra structures. I would like also to I don't know if you have some question. I would like to briefly introduce the last libraries of today. So I'm going to introduce the matplotlib library. No, so I can write here So matplotlib is a plotting library for Python, and it is used along with NumPy. Just from the name, you can see that matplotlib is something that provides an environment which is very similar to MATLAB. So MATLAB is very useful to have very nice plots. And so this library is built to recreate plots in a kind of graphical way that is very close to MATLAB. So one of the most important functions in matplotlib is pyplot, which is used to plot data. But we can start just how to import matplotlib. So we can import again NumPy as np, but we can import matplotlib in a different way. So in this way, we can also import matplotlib in the similar way of NumPy, but a different thing. Just since I want to show you just a brief example, I would like to just import only the function pyplot from the library matplotlib. So from matplotlib, I would like to import the function pyplot and use it as plt. So now I have imported just the function pyplot from matplotlib. And I can take one example. For instance, I can create an array of values between 1 and 10. I can use this function of NumPy arrange. So from 1 to 10, I'm going to use from 1. I'm going to write 1 to 11 because the last element is not considered. And here is my array of values. So I can multiply each element of x by 2. For instance, I can write that I want to multiply each element of x by 2 and add another number, I don't know, 5. And this is the output result. So now I want to plot the result. So I can, as in MATLAB, I can use the function of pyplot, and I can write the title. For example, the title of our figure. Sorry, I didn't want to plot this, to execute this. So I can also write, so here is the figure with the title. I can write the label of the axis, for instance, the label for the for x, plt y label is the label of the axis y. And in order to plot, we can use plt plot of the two elements, which are x and y. So I'm expecting a line that can go across this point. And in order to show the results, we use pyplot show. So if I execute this code, I have the figure. So we have a line in this point for the x and y, and we have a caption, a title for the figure, the caption for the axis, and so on. This is just a very simple example, but we can also have, I don't know, subplots and so on. So for example, I can just tell you a very brief example of having, for instance, we can plot a sine and a cosine, just to show you also how to write a sine and cosine. So I can use np range that goes from 0 to if you want to np.py and the step is 0.1, so I can write the sign as the sign and np.sign and the cosine as np cos of x. So we can set a subplot grid, so we can plot the sine and cosine in subplots. So very similar to MATLAB. I can write the subplot. The subplot works as in MATLAB, so I can define a grid of 2 rows and 1 column, and I choose the first row. And in the first row, I plot plt plot x and the sign, and I can put the title, plt title, which is sign. I can take the second subplot, so subplot. So is the same, but I choose the second row, and plt plot x and y cosine, and the plt title is cosine. We can write plt show, and I hope to have written in the correct way. Okay, so it is correct, and I have the sine and the cosine. So I have 2 subplots, and I have the sine and the cosine of our function. So I would like to stop here for today, and I will send you a complete notebook of all the things that we saw today, some exercises in order to have some practice at home. So I can also give you some useful links in order to have some different exercises. So if you want to have some to go a little bit into detail of, and the slides, you can find the slides that are already on my website. Okay, guys, see you. So if you have other questions also later, you can write me an email. You can ask me for one-to-one office hour and so on. So we can meet next week. And so thank you everyone for being here, and see you next week. Bye.